Welcome to Maths with EJD. In this video, we're still talking about set theory, and here we're talking about real-life applications of Cartesian products. Real-life application, real-life applications of Cartesian products. So that's what this is about. Okay. Real-life applications of Cartesian products, actually. So real-life applications of Cartesian products. Cartesian products, like that. So first of all, let's talk about products of n finite sets. Product of n finite sets. Okay. So the Cartesian product of n finite sets is a powerful concept, used to determine all possible combinations across multiple categories. And we get to use this kind of idea every day in the things we do. So all possible combinations in multiple categories. Okay. So this principle finds applications in various real life scenarios where combining different options or criteria is necessary. So it's more like you want to make a decision, and then there are a couple of factors to consider. So for each decision you have to make, you have to consider, two or more things. So that is where Cartesian product becomes pretty important. So let's first of all start with the first example. Let's look at an example on meal combinations. Say you have an outing or something, or you want to have a family dinner or whatever. So that's our example one, meal combinations. So Cartesian product can easily be useful in this case. So imagine you're at a restaurant with multiple options. Okay, so just imagine you are at a restaurant with multiple options, multiple options for foods, drinks, and desserts, right? So, I mean, that's to tell you that you can come up with a scientific way of choosing what to eat. And that's what Cartesian product can do for you. So the restaurant offers three types of foods, say pizza, pasta, and salad. Then it offers two types of drinks. Let's say water and soda. And lastly, it offers two types of desserts. Two types of desserts. Say cake and ice cream. Cake and ice cream. Okay. So, I mean, this is what you have. You go for a restaurant to a restaurant and you have food, drink, and dessert. And you want to see what possible ways in which you can combine this thing. Already from what you have learned, you should just know three types of food, two types of drinks, and two types of desserts. 3 times 2 times 2, that will give you 12. So there are 12 possible combinations you can have. So this is a very scientific way of knowing the kind of combinations you can have. Of course, that is assuming that you have no restrictions of any sort. So now let's look at how this works. So we can say that, okay, I guess I want to change here. So the Cartesian product, right? The Cartesian product, the Cartesian product of the sets representing these options. These options gives you all possible combinations. So if you want to know all possible combinations, then you can come to Cartesian products, all possible meal combinations. If you want to know all possible meal combinations, Cartesian products can help you out with that. So, you're talking about foods. So you have foods by drinks, by desserts, right? Food by drink by dessert. That's a possible combination you can have this. So now, yeah, for the foods, right? For the foods, you have pizza, pasta, salad. Okay. And then for the drinks, you have water. You have water and soda. And then desserts, for the desserts, you have cake and ice cream. Cake and ice cream, right? Cake and ice cream. So to work out the possible combinations, you already know that the cardinality of the meal combinations of the possible meal combinations will be that the cardinality of foods by drinks by desserts, and that is equal to the cardinality of foods multiplied by the cardinality of drinks multiplied by the cardinality of desserts. In case you've forgotten, the cardinality of a set is the number of elements it contains. So 3 types of foods, 2 types of drinks, and 2 types of desserts. That means you're going to have 12 possible meal combinations. Okay? You're going to have 12 possible meal combinations. So if you want to get to it, so I mean, with this now, there's no way, there are no two ways about it. There are 12 possible ways to combine all of these things. So, and if you want to do that, so you just know that foods by drinks by desserts will just be the set of all these possibilities. So you can have pizza, you can have pizza, you can have pizza water cake, pizza water cake. You can have pizza water ice cream. Okay, that's another possibility, that making 2. Then of course, you can have pizza you can have pizza water cake, you can have pizza water ice cream. Then you can have pizza soda cake. Then you can have pizza soda ice cream. That's another possible combination. Okay. Then you can have pasta water cake, pasta water ice cream, pasta water cake, and you can have pasta water ice cream. In the same way, you can have pasta soda cake, pasta soda cake, and you can have pasta soda ice cream. Okay. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. So, and we know we can have 12 all together. So again, you can have salad. You can have salad, water, cake, and you can have salad, water, ice cream. Salad, water, ice cream. Okay. Finally, I guess. And not finally yet. You can have pasta. Oh yeah, I think you have the last two triples. Salad, water, cake, salad, water, ice cream. So you can have salad, soda, cake, and salad, soda, ice cream, ice cream, ice cream. So these are the 12 possibilities. Okay. These are the 12 possibilities you can have from what we have there. So for your meal combinations, maybe you're a caterer or something, or you get to serve food somewhere. This is something you may want to consider. Okay. So what if you have, okay, I may not have to go all the way to describe this much because I mean I believe the main idea uh should have sunk in by now. So can we talk about multi-criteria decision making? So we have example 2, multi-criteria decision making, multi-criteria criteria decision making. So you want to make some kind of decision based on certain factors, right? So this example 2 is useful for that. So multi-criteria decision making. Say that in a decision-making process, especially in business or project management, decisions are often based on multiple criteria such as cost, quality, and time. Okay, cost, quality, time. Suppose a project manager needs to evaluate several project plans, each with different levels of cost. Let's say you have costs, and the cost can be uh low, low cost, medium cost, or high cost. Low, medium, high. Those are the levels of cost you have. Of course, you know the cardinality of the costs is 3. So low, medium, high. Then you have quality. You have quality. Let's say the quality is basic quality or premium quality. Premium quality. So that implies that the cardinality of quality, that's the number of elements of in the quality, is 2. And then you now have the time. So what range of time are we considering? So is it short term? Is it long term? We can even include medium term, but let's say short term and long term. So these are the criteria you have. And of course, the cardinality of this set of time is actually 2 also. Interestingly, we have 3, 2, 2 still. So again, it means that uh all possible scenario. So we can say, therefore, all possible, all possible scenario, scenario, all possible scenarios would be equal to, the cardinality would be equal to 3 times 2, which is 12. So there are 12 possible combinations. So so if you want to even consider, if you want to go down to it and see, so all the possibilities. So I won't do all of it, but I'll give you just a few. So you just know that the Cartesian product of costs by quality by time is simply, you're going to have 12 of them. So I'll just do a few and that'll be it. So maybe I'll do 2 or 3. So you can have low cost, basic quality, short term. Low cost, basic quality, short term. Short term. That's one thing you can have. You can have low cost. You can have low cost, basic quality, long term. So, you can look at each of these scenarios to evaluate what works best for your company. So these are the first two, Let me also go to the last two. So the last two would be something like high basic short, high cost. So maybe high cost, basic quality, short term. And then you can have high quality, high quality. I mean, high cost rather, high cost. You can have high cost, premium quality long term, high cost, premium quality long term. Now, this is not everything, but you already know everything should be 12. So you just go around the combinations and do it like that. So there are many things in between that I've missed out. So, but I mean, it's just about, okay, we can even do something diagrammatic. Say low, it can be low basic short. That's one. It can be low basic long. That's another one. So it can be, say, medium basic short. It can be medium basic long. Okay, that'll be so messy, right? That'll be really messy. So, but I mean, you can take this as a practice. Just list out all the possible 12 combinations, right? Since we know that we are going to have 12 already. Okay, so that's if you want to make decision based on multiple criteria. Then let's talk about production variations in e-commerce. So production variations in e-commerce. Let's say that, okay, production variation in e-commerce. Example 3, production variation in e-commerce, Okay, so here now, in an e-commerce setting, a store might offer a product in different sizes, colors, and materials. For example, you can have a t-shirt available in 3 sizes. So here you have sizes, and the sizes are, say, small, medium, large, and the cardinality of the sizes is 3, okay? Then, and the colors can come in. So let's say you have colors, and the colors are, say, red, blue, green, orange. Red, blue, green, orange. So the cardinality for the colors will be 4 in that case. And let's say you have uh 2 materials. Let's say you have 2 materials. The materials are cotton, and polyester. Cotton and polyester. So of course, the cardinality of the materials is 2. So then we see that all possible combinations, all possible combinations. So all, we can say all shirt or all t-shirt variations, all t-shirt variations that you can ever have would be 3 times 4 times 2. That is 24. So you can have 24 possible combinations, and some of those possible combinations might be without putting it in a set now. So you can have small red cotton t-shirts, small red cotton t-shirts. I mean, I'll just take randomly. So we already know we are going to have 24. So I'm just going to take some randomly. So you can have say large orange cotton t-shirts like that. Then you can have, say, medium. You can have green, medium green polyester t-shirts. So these are just 3 possibilities out of all the 24. So you can deal with all that. That's for the Cartesian product of sizes by colors by materials. So this can help you to be more organized if you make t-shirts in different colors and materials. Okay, so all of these things are supposed to help us in our decision making processes. Okay, so can we talk about travel planning? Travel planning. Imagine that you want to travel, and let's talk about example 4, travel planning, example 4. So as assignments, you can do as practice, right? You can actually make sure all these ones I'm leaving out, try to list all the possibilities. It's pretty simple. And if you have something that involves all these kind of things, you can actually adopt Cartesian products in what you do to be more organized. Okay, so travel planning is what we are talking about next. Travel planning. So when planning a trip, you may consider different options for transportation. So you have transportation, 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 and maybe you have possibilities of flight or train, flight, train, or say, what else can you take? You can also take a bus, So in that case, the cardinality of train is 3. And then we go for the next thing is accommodation. Accommodation. Depending on the cost you are willing to go for, you can go to a hotel, you can go to a hostel. I've had to live in hostel before to cut costs, So Airbnb is also another option. So in that case, the cardinality for accommodation is also 3. And then lastly, you may want to consider the activities you want to do in your destination. So for activities, so say you may want to go for sightseeing. Okay, you may want to go hiking, and you may want to go dining. Okay, so the cardinality of these activities, so this is accommodation, so this is ACC if I like, and this is activities, that's also 3. So the possibility, all the possible accommodations, or rather possible all the possible combinations, all the possible combinations will be equal to 3 times 3 times 3, which is 27. So you can combine this thing in 27 different ways. So if you are into tourism, travel planning, and things like that, this can also be of help to you. So it can also help you to do your pricing like that. So, and make your work organized. So some possibilities would be, you might have somebody who is going by flight, living in a hotel, staying in a hotel, and then the person is going dining. That's one option out of 27. You can have someone who is going by bus, lodging in an Airbnb, okay? And the person is going hiking, all right? That's another possibility out of 27. Then you can have someone who is going by train, staying in a hostel, and the person goes sightseeing. Sightseeing. These are three possibilities, and so on and so forth. So you can fill up all the rest. This is 3 out of 27. So you have 24 other possible options. So this helps you to get a kind of helicopter view of whatever you are doing. Okay. So the last example I like to give is about scientific experiments. Say you are conducting experiments and you have some combinations possible. So say example 5, and here we're talking about designing experiments. So, one thing about research is that it's better you already have an idea of where you're going to, so that especially if it involves data collection, you need to design your experiment in such a way that you get a kind of data, and the data is organized in a way that it will be easy for you to analyze. So consider a scenario such that in the scientific research, experiments are often designed by varying different factors such as temperature, pressure, and concentration. So we have temperature, pressure, and concentration. Okay. So for temperature now, say you have for temperature, you have low, medium, and high. Low, medium, and high. Or let me just say low and high. Let me just stop at low and high, right? Low. So you might have low temperature and high temperature. Maybe that's all you care about. And then you have, okay, let's do low, medium, and high. Let's do low, medium, and high. Low, medium, and high. Low, medium, and high. Okay. Low, medium, and high. That's for temperature. So the cardinality of temperature you can see is 3 already. Then for pressure, say you are concerned about atmospheric pressure, that's like normal pressure, atmospheric pressure, or you want some high pressure, made possible by some equipment. So the cardinality of your pressure is simply 2. And then you also have the concentration. You want it to be 1 m. I mean, maybe 1 mole or something. Here you have 2 mole, 3 mole, and 4 mole, or whatever that is. And then the cardinality of that concentration is actually 4, right? It's 4. So in this case now, the Cartesian product will tell you, it gives you 24 unique experimental conditions, which you can use to systematically study the effects of varying each factor. So once you have all the possible combinations, you can study all the possibilities and be sure that nothing has been left out. So Cartesian product actually helps you to be very organized and orderly. So in whatever it is you're using it for. So in this case now, you have all possible unique experimental conditions, is the product of the cardinality of each condition. So that's 3 times 2 times 4. And then you have 24 possible conditions. So I'll just give some random possibilities, right? So say you can have low temperature, high pressure, then 4m. That's one possibility. You can have medium temperature, then atmospheric pressure, and 1m concentration. So you can have plenty things. You can have up to 24. So you can put all of that together so that it all works. So as a way of practicing, you can do all of this. So this example actually illustrates how the Cartesian product of n finite sets can be used to explore all possible combinations in various practical contexts, from meal planning to complex decision-making processes and scientific experiments. So if you're doing something that involves different factors, so this is one way to be highly organized. and to get things right. So be sure to sign up to this channel, subscribe, hit the notification bell so you can always get alerted when a new video is released. Of course, be sure to comment, like, and share. Thanks for stopping by. See you later. Bye.